fine. All right. And David is frantically on his way. So, I don't know if anybody knows, this time next week, you are going to be in the middle of your BC exam. This is big. This is big. One more week. You can do anything for one more week. I should know not to stand right in front of the camera and get closer. It adds a couple of pounds. It's all good. We are in this together. There is no new material to learn. It is about mastery and mastering things deeply. You guys all did the 3-a-day, day 1 last night. You can just tear that out. If there's crinkly edges, Lewis, please get rid of the crinkly edges. Oh my God, get rid of the crinkly edges. Thank you very much. Or it was Stevens. Yeah, Andrew, make sure you get rid of your crinkly edges. Tonight, homework, any guesses?
Day 2.
3-a-day, day 2. It's a really easy system. Someone tell David when he gets back in the room. Now here's the thing. I don't want you to worry about what is my grade on this. I'm not actually grading them. What I'm going to do every night is go through, I'm going to score them, I'm going to give you feedback, I'm going to score just like the College Board would score, and you'll get them back the next day so that you're constantly getting feedback and getting practice with the free response. Hopefully last night's experience was a pretty good one, relatively good one.
Yeah.
Right. My goal is to make sure that when next Tuesday rolls around, you are ready for everything. Outside of class, a lot of free response work is going to be happening. Inside class, we're going to focus on multiple choice for the next 4 days. But we're going to do it with a plan. Surprise, there's a plan. There's always a plan. We're going to move into what is called Blitz Mode. One of the calculus teachers at the S-Prep West came up with this idea, and so we're going to roll with this for the first time ever. I'm really excited. The idea with the Blitz is you have to just accomplish as much as you possibly can in a very short period of time. To help with that process, there's the binder. I'll stop thinking bad thoughts about you. Okay, I was never thinking bad thoughts about you. Because you know where your calculator is, right? You're like a good calculator owner? Responsible, taking care of things? Yeah.
Take it out right now.
4 o'clock in the morning, I get up to go pee and drink a little bit of water, and there's an email from Polymone, a whole 2-paragraph basically to say, I don't know where my calculator is. And I just responded back, and I was like, I had nothing to say. I still have nothing to say. No, it really was, it was like a Harry Potter novel. Basically, and the punchline was, I don't know where my calculator is. Help me.
What did you have to say?
I'll forward it to everybody. Anyway, so free response outside of class, multiple choice inside of class. What you can expect is in the last 20 minutes of class today, you're going to be in multiple choice blitz mode. You'll have 20 minutes to do 10 multiple choice questions. Also not for a grade, right? We don't have to worry about grade. Dismiss grade. Focus on experience. Carmen, disconnect from grade for a little while, okay? But it works so well. I know. Focus on experience. Focus on the learning experience. All right, that's about it. So here's what's going to happen. You may have noticed these wonderful, beautiful little signs. It's almost like being like at somebody's wedding. Okay, we can thank Ms. Stuckenschneider at Northside for this idea. I saw it once and I was like, oh my God, have to have those. So I stole these from her. Don't let her know. She doesn't watch this video. Anyway, so what you're going to do is you're going to do a station rotation. The 10 of you are going to do a station rotation. I want you to focus on multiple choice. There are 5 different stations. Over here we have tricky A-B questions. Over here we have advanced integration. Over here we have series. Over here we have
Vector value.
vectors. Over here we have differential equations. These are all the BC things. The tricky A-B questions are exactly that. They are tricky A-B questions that are fair game on your exam. Between now and 9:19, I would recommend that you go to 2 stations. Split your time any way you want to. You all are full grown. Split your time in whatever way makes the most sense for you. If you want to do advanced integration techniques, that's a good idea. I think for Andrew, for Stephen, for Lewis, who were here yesterday to do a review of advanced integration techniques, I wouldn't go there. I would maybe go over to differential equations. I'd maybe spend some time over here at series. I would recommend that you focus in class on the multiple choice. okay? And your goal is just do them as quickly as you can. Feel free to grab one of the handouts that are there in the middle of the table. There's enough copies. Everybody can get one, keep one. We're going to do this today. We're going to do this on Thursday. Everybody good? Now, while you guys are doing that, I'm actually going to film some solutions to the free response that you can watch later if you want to, that students at other campuses can watch because, you know, they don't get the live version all the time, but that's the goal. Everybody good? All right, so we're going to do this till 9:19. That's about 25 minutes. So why don't you pick your first station? I'm going to set my alarm, and then we're going to go. Pick your station. Which means you're moving to your station. Okay, Stephen, is the camera good so that I can write on both boards?
It will be.
Okay.
And it is.
And it is. Make it so, sir. Okay. And I'm thinking about the video. So is everybody locked in at a good place? Mm-hmm. Advanced integration techniques over here, vectors, and then series. You've got the handout, you've got my solutions. Definitely feel free to help each other out. Okay, we are in this together. At 9, I'll say 9:07, I'll set my alarm for about 12 minutes. We're gonna move to another station. Although you are full grown, you could technically choose to stay at the same station. I don't think that's the smart thing to do. While you guys are doing that, I'm gonna film. So I'm going to work on the differential equations problem. It's going to be weird for me because there's no one I'm actually going to ask any questions to because you all are busy working in your station. So it's just me, the camera, and we'll see where we go. All right, number 6. Consider this is in the differential equation station packet. Consider the differential equation dy dx equals 6x squared minus x squared y. Let y equal f of x be the particular solution of this differential equation with the initial condition f of -1 is equal to 2. All right, differential equation. I know differential equation just means an equation that involves a derivative. We've got an initial condition. Great. Oops. A, use Euler's method with 2 steps of equal size starting at x equals -1 to approximate f of 0. Euler's method, this was the idea of you start with a tangent line, you're going to use that tangent line to get you to the next point where you build another tangent line and you move along to the one after that. So I know that f of -1 is 2, so that means that if x equals -1, y is equal to 2. I know that my goal is to evaluate f of 0. That means I'm moving from x equals -1 to x equals 0. And they say 2 steps of equal size. So my step size is going to be 1/2 or 0.5. We know that f of -1 is 2. I need to get an approximation for f of -0.5. I take a half step towards my goal. Lewis, is everything okay? Yeah. Okay. So first thing we're going to need is we need the slope. I need the slope at -1, 2. The way I get the slope at that point is I'm going to go to my differential equation. I'm going to plug in the x and the y values. And so I've got 6 times -1 squared minus -1 squared times 2. So that's 6 minus 2, 4. That's my slope. That means that my first tangent line has an equation of 4 times x plus 1 plus 2. I use the differential equation to find the slope. I use the slope to build the tangent line, and why I care about the tangent line is that now the tangent line is going to be used to approximate the value of the function at negative 0.5. So f of negative 0.5 is approximately 4 times negative 0.5 plus 1 plus 2. Because I'm going to have to do more calculations, I do have to simplify here. That's 0.5 times 4 plus 2 is 4. That gives me the point negative 0.5, comma 4. And all I'm going to do, I'm going to go and do it again. So find the slope of the tangent line at negative 0.5, comma 4. That's going to be 6 times negative 0.5 squared minus negative 0.5 squared times 4. That's a little bit ugly. Negative 0.5 squared is really, that's 0.25, so that's a fourth. 6 times 1/4 is 6/4. I'm going to reduce that to 3/2. Negative 0.5 squared, we've already said it's a fourth, times 4 is going to be 1. 3/2 minus 1 is a half. That tells me the slope. That means the second tangent line is going to be 1/2 is the slope. X minus a negative 0.5, which is x plus 0.5. Then add 4, that's your second tangent line. I'm going to use that now to approximate f of 0. F of 0 is approximately 1/2 of 0 plus 0.5 plus 4. And if all goes well, you get 4.25. And nobody's at the differential equation station to tell me that I did all that correctly. Well, let's double check. Good news, I did. Whew. All right, so that's A. Gonna check that off the list. That would be worth 2 points. For all the folks working at the stations, are we okay? Mm-hmm. Right, you've got the pink, which is not just the answers, but it should have the workout solutions on the back as well. Feel free to look at these. All right, and where'd Mr. Tarek go? All right. All right, part B. At the point negative 1 comma 2, d squared y dx squared is negative 12. D squared y dx squared at negative 1, 2 is negative 12. Find the second degree Taylor polynomial of f at x equals negative 1. This is one of these places where the College Board is being a little tricky. You're doing differential equations, and now they're mixing in other stuff. What I know is they want the degree 2 Taylor polynomial, bless you, centered at negative 1. Well, how does that work? It's always the value of your function at the center plus the value of the derivative at the center times x minus your center plus the value of the second derivative at the center divided by 2 factorial x minus your center squared. If I clean this up a little bit, well, what do we know? We know f of negative 1 is 2. F prime of negative 1 is the derivative at x equals negative 1, which means your slope. And we found that out earlier to be 4 times x plus 1. Plus I need f double prime at negative 1. F double prime is the value of the second derivative. That's why they gave you this information. So negative 12 over 2 times x plus 1 squared. And let me double check, make sure I didn't lie to anybody. Done. That was part B. Last one, we're going to go to part C. In part C, what do they want? Find the particular solution, which means solve the differential equation. Find a particular solution to the differential equation with the initial condition f of negative 1 is equal to 2. Well, what do I know? I know that dy dx is equal to 6x squared minus x squared y. I know that f of negative 1 is 2. And I know they want me to solve the differential equation. To solve the differential equation, one of the things that we do is we separate variables. We were really good at that. This one's a little bit trickier because I've got the x's and y's mixed in together on the right-hand side. A thing that you could do on the right, if you see it, is factor out the x squared times 6 minus y. Now when you separate the variables, you get dy equals x squared times 6 minus y dx. To separate the variables, we're going to divide. Dy over 6 minus y equals x squared dx. On the right, everything's in terms of x and dx. On the left, everything's in terms of y and dy. First point earned. And from here, we integrate both sides. If you don't correctly separate the variables, you cannot earn any of the points after this. So let's keep going. Integrate x squared with respect to x. We're going to get 1/3 x cubed plus Charlie. The integral of dy over 6 minus y. You want to be careful. Yes, it involves natural log, but it's going to be the absolute natural log of the absolute value of 6 minus y. And I'm going to need a negative in front. If you're not sure about that negative, check it by taking the derivative. The derivative would be negative 1 over 6 minus y times the derivative on the inside, which involves the chain rule, which is negative 1. It's that multiplying of negative 1 through the chain rule, why I need the negative over here. According to the scoring rubric, 1 point for each antiderivative, 1 point for the constant of integration. We are in a really good place. You've already separated the variables. You've already integrated. The only thing left is to solve for y. If I know that we have negative absolute value, negative natural log absolute value of 6 minus y, 1/3 x cubed plus c, I'm going to solve for y. I can multiply by the negative to get natural log absolute value of 6 minus y is negative 1/3 x cubed, technically minus c, but this is that super constant. C is the constant of integration. Whether it's positive or negative, I can still just assume positive. To solve for y, I'm going to exponentiate both sides. These guys cancel. Absolute value of 6 minus y is e to the negative 1/3 x cubed plus c. If you remember, what we would do next is make this e to the negative 1/3 x cubed times e to the c. When the bases are the same and you're multiplying, add the exponents. E to the c, that's our friend Super Charlie. Absolute value of 6 minus y is c, e to the negative 1/3 x cubed. Get rid of the absolute values by doing plus or minus. C is a constant. Whether it's positive or negative, I can group that together as Super Charlie to get c, e to the negative 1/3 x cubed. We're almost there. You just need to solve for y. You could subtract 6 to the other side and then multiply everything through by a negative. I'm going to get y equals c, e to the negative 1/3 x cubed plus 6. Now use your initial condition. You know that if x equals negative 1, y has to be 2, which is, what is that, 2 equals c. Okay. For all the friends in the room, I would strongly recommend you leave the station that you're at and pick something else. We're going to have another full day where you can do this. Right now, I just want exposure and lots of at-bats. So while you move, I'll pause the action here. Tricky AB questions over here, advanced integration over there, series, vector valued parametric polar curves, differential equations over here with Stephen. Make sure you grab a copy of the handout, but you leave the solutions, please. All right. Doing okay? Have the first week. But that's why we're going to. Okay. All right, 12 minutes. Anyway, for the friends on the video, we finished this off. I was plugging in -1 for x, plugging in 2 for y. 2 equals c e to the, what is that, 1/3 plus 6. All I need to do is solve for c. I don't have to do anything fancy. I'm going to subtract 6. -4 equals c e to the 1/3. c is going to be -4 divided by e to the -1/3. Your final answer, pull everything together. Y equals -4 over e to the 1/3 times e to the -1/3 x cubed plus 6. I'm sure there are some clever ways we can simplify this answer. Not interested in the simplification, just interested in the process. The one thing I would say about this before we totally leave differential equations is when we're really doing a good job with differential equations, we look for domain restrictions. We look for any domain restrictions in the initial differential equation. I'm not dividing by anything, so I'm not worried about division by 0. I don't have square roots. I'm not worried about square roots of negative numbers. We seem to be okay here. We also look for domain restrictions in the final answer. The only place that I have a variable is up in the exponent. That shouldn't cause any domain restrictions. So this is going to be your particular solution for all values of x. Not bad. I think it's a pretty good question. You've got a mix of Euler's method, you've got some Taylor series expansion stuff happening, and then you've got separation of variables. All the big ideas mixed into one question. This is what we need to be ready for. Okay, I'm going to spend some time with all the folks at the stations. We'll come back, and I'm going to film advanced integration techniques. Seriously? So I picked up homework from Myra, Celeste, Ilay, Carmen, Andrew, Lewis, Stephen, Palimon, it's an emotional experience over here right now. Thank you very much. So for all the friends in the room, when the timer goes off in a couple of minutes, I'm going to have you guys switch into the Blitz mode, which is going to be 10 multiple choice questions, 20 minutes, completely on your own, no help from anybody. So that I can do a really good job with the advanced integration techniques video, I'm wondering if you guys are going to be okay if I keep filming while you're working the multiple choice. It's not for a grade. So like we don't need to worry about this, Carmen. It's not for grade. Okay, the A+ is going to be like pretty much locked in. Myra, you're going to be okay? Andrew, you're going to be okay? David, all the friends? Okay, good. Then I'm going to keep filming. Tomorrow, with it being a Wednesday, we're not going to do the stations. You're going to do an extended blitz. 15 multiple choice questions, 30 minutes. They're all VC questions, which means you're going to come in and be testing the whole time. Okay, not for a grade. We don't have to worry about grade. I want you to have the experience, because what's going to happen between now and the end of the day on Friday, you're going to do 45 multiple choice questions. You're going to do a whole multiple choice practice test. You're going to have done all these free response. Sunday night, I'm going to do my Excel magic, pull all the data together so that on Monday I can give you your data sheet that says, hey, you're really rocking the house with vectors and polars and parametric, but series, you're stinking up the place. Or advanced integration techniques, you don't seem to know any of them. Okay? So like that's really the goal. I want you guys to just like push, 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 push. I'll get some really good data this weekend. Monday, I'll give you the data sheet, and then you know how to spend your last moments on this planet. Oh, no, that's a bit extreme. Your last moments as you study for the VC
I
test.
mean, after this test, what matters?
There's still the AP English exam next Wednesday, and I'm filming this, and Mr. Garcia might be watching. Who
My
knows?
question still.
Okay, moving on. All right, so then I am going to deliver the stuff so that you guys have it. The test that I'm going to give you right now, you are going to keep. It goes in the practice test section of your survival guide. That's the only place that it goes. Don't start on it yet. That would be cheating. There you go.
Oh, it's all of this.
Oh my God.
What happened?
This is the whole practice test. Okay. Here's your answer sheet. Please put your name on it. When the timer goes off,
What do you think the word open is?
I would actually do it if I was going along with
one for you,
Oh, that's
one for you. All right. Make sure we are all 100% on the same page here. So it's 9:19. You have the next 20 minutes, which is the rest of this period. We're not going to end late, to do 10 multiple choice questions. Not a rando selection of 10, the first 10. You need to be operating at a rate of 2 minutes per question. One of the teachers that I work with sets her timer to go off every 2 minutes. I can think of nothing worse. This seems like the fourth level of hell if there is a timer going off every 2 minutes. Is everybody okay if we don't do a timer that goes off every 2 minutes? I-
Every minute. You know what you really do every minute.
Oh, good. Okay. All right.
Please don't turn it off.
Beep, 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 beep. All right. 20 minutes. First 10 questions, don't cheat. Don't look at question number 11. The only thing I'm going to pick up is this answer sheet from you. I know there's a lot of papers on the table and life is messy. I'm suppressing my OCD right now, it's all good. Okay, you've got 20 minutes.
No.
Oh, yes, no. You now have 19 minutes and 51 seconds. Was that not helpful?
There's nothing wrong with it.
Okay. All right. All right, here we go. So what I'm filming now is for advanced integration techniques. This is the first question. Hopefully we're going to make it to the second one as well. Let R be the shaded region bounded by the graph of y equals x e to the x squared. Okay, and the line y equals negative 2x. Let me take an educated guess here. This is probably the graph of y equals x e to the x squared. This is probably the graph of y equals negative 2x down here. And the vertical line x equals 1. Okay, there's my vertical line. Find the area, okay? Area, what do I know? I know if I want the area, not volume or revolution, I think about my little representative slices. Every slice goes from the top curve to the bottom curve. And so when I do my integral, I'm going to do the integral of x e to the negative x squared minus negative 2x. Integrate with respect to x. My limits of integration are going to go from 0 to 1. And if I was a betting man, setting up that original integral is going to get you the first point. Now, from here, we're going to have to get a little bit creative. We're integrating from 0 to 1, x e to the x squared plus 2x with respect to x. I would not at all be surprised if at this point in your lives, some of you are able to see the x e to the x squared and right away know that this is going to be substitution. If you're able to do that in your head, great. If not, what we're going to do is we're going to say, well, the baby is probably x squared, which means that the derivative is 2x dx. To get this guy here, it would be 1/2 of the du. And so what's going to happen is you're going to integrate the integral of x e to the x squared is 1/2 e to the x squared. The integral of 2x is x squared. Integrate from 0 to 1. Plug in. You're going to get 1/2 e to the 1 plus 1 minus 1/2 e to the 0 plus 0. Done. If you're not a big fan of what just happened there, if this step here was a bit of a mystery, here's another option. Break this integral into two different integrals. And the reason that I'm going to break this into two different integrals is that this part over here should be really easy to integrate. The integral of 2x is x squared. Evaluate from 0 to 1. This part, we would do integration and say u is x squared, du is 2x dx, so 1/2 of du is x dx. In your substitution, you're going to get 1/2 e to the u du. You have to change the limits of integration. This meant x equals 0. Now this is going to be u equals 0. We had x equals 1, u is x squared, u is 1. From here, find the antiderivative, evaluate, whatever you get for an answer, add on to this guy over here. Done and done. That was part A. Part B, write, but do not evaluate, please do not evaluate, an integral that gives the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. Y equals negative 2 is a horizontal line down here. In fact, I think if I had drawn that well, y equals negative 2 would actually pass through this point right here. I want to take region R. I want to revolve around the line y equals negative 2. Again, if I look at my little slice, if I'm spinning that slice around the line y equals negative 2, what I'm going to get is a reflection down here. The shape, thank you Miss Blakely for teaching me how to draw this. This is going to give me half of my washer. I only need to see half. so that now I can go through and say, well, the volume, I can see that this is a hollow object, is going to be pi. Because it's hollow, I'm using washers. There's a big radius squared, there's a small radius squared. I'm integrating from 0 to 1. Your big radius goes from the axis of rotation to that outer curve, which is x e to the negative x squared. The total length is x e to the x squared minus negative 2. The inner radius goes from the axis of rotation up to that line, and that's going to be, what is that, negative 2x minus negative 2, or negative 2x plus 2, the whole thing squared dx. All they wanted was a setup. I would not do anything more than that. All right, just wanted to go and check the answers. All right, part C, write, but do not evaluate an integral expression involving one or more integrals that gives the perimeter. Well, perimeter, it's been a while since we've worked with perimeter, but if you remember, maybe you don't, to find the perimeter, first of all, we're going to have to figure out how long this curving piece is. We're going to have to figure out how long this part is, and we're going to have to figure out how long that is. There's 3 different lengths that I need. The perimeter is going to be the first length added to the second length added to the third length. Let me call this guy here first length. There's the second length. There's the third length. Well, this first length is just a straight line. So I could just say, well, I know I'm connecting the origin, 0, 0, to the point, this is the point 1 comma negative 2. This is a straight line. So I could just say that L1, I could use the distance formula, which says change in the y values, or we could do change in x values first, 0 minus 1 squared, change in the y values squared, and clean it up if you want to. That's going to be 1. Negative 2, minus negative 2 is 2. 2 squared is 4. That first length is square root of 5. Check. The second length goes from this point 1, negative 2 up here to this point. This point's a little bit trickier. We know the x value is 1, and it has to be on the curve x e to the x squared. The y value is found by plugging in. 1 times e to the 1 squared is just e. That second length is going to be found by looking at the vertical distance from 1e to 1 negative 2. That's just going to be top minus bottom, or e plus 2. That's the second length. The third length, now this is the one that requires your knowing a little bit of calculus. Everything else you could do back in geometry. The way that we find the third length is we're going to do an integral from x equals 0 to x equals 1. It's the square root of 1 plus the derivative squared. We need to know the derivative of x e to the x squared. To find the derivative, you're going to have to use the product rule. So that's 1 times e to the x squared, plus, now leave the x alone, e to the x squared, times the derivative of x squared, which is 2x. This is the third length. This is obviously the tricky length to find. Your perimeter is what you get when you add all these together. So we're going to have square root of 5 plus the second length, e plus 2, plus the third length, I'm going to get out of the way in a second, integral from 0 to 1, 1 plus e to the x squared plus 2x squared, e to the x squared squared, and integrate with respect to x. terms of awarding points, if you correctly found the derivative, you get 1 point. If you correctly set up this integral, a 2nd point. The constants together get you the 3rd point. That would be a nice, perfect 9-point solution for parts A, B, and C on this first question. We've got about 9 minutes left. I'm going to do a quick lap around the room, make sure everybody's doing okay. You guys doing okay? You finding problems that we figured out? And so maybe not so bad. Do the best you can and analyze the data. Make sure you get all of your lunch you can, because that's the temptation of the wrong. Because it's the temptation to give up and cry. It's not probably too hard. All your answers are on the answer sheet. Okay. Friends back here, are we finding some questions that we're still good about? Maybe not tons and tons. Some. Care about some. Okay. Nobody's crying yet, so that's good. No, he's not. He wouldn't cry. How distracting is it for me to be doing this while you guys are testing? Okay, because what I'd like to do is do this again tomorrow so I can get like more video, I can post that video, I can push that out to you guys, and you still have this experience. I will not be doing this next Tuesday when you're taking the exam. Man, God, that would be awesome. Instead, I'll just sit outside the room and sacrifice a chicken. Or a 6th grader, and some one of those.
You should be taking some.
We got a lot of 6th graders. Chicken, that's hard to come by.
I know that.
You know. Of course you do. All right.